When looking at electron configurations, primary things we need to remember are to find the total number of electrons that we need to use, and then to remember the order that the orbitals fill up in. Again, looking at our periodic table, we can find the number of electrons for each of these. Technetium is element 43, therefore has 43 electrons. Cesium has 55 electrons, but we are dealing with the cesium plus ion, so that means we've lost an electron, and so we should only account for 54 in this configuration. Next, we want to be able to remember our order of orbitals, and you may recall we said we could do that in the following way. We write out our chart. And then we can get our order by drawing our arrows in. And I'll stop at this point because that's as far as we need to go for this problem. It's also important for us to remember the number of electrons that each type of orbital can hold. So the s orbital can hold 2 electrons, 6 for the p, 10 for the d, and 14 for f. So from here, we're just going to start by filling in orbitals until we've used up all of our electrons. Always remember, as we saw over here, after 4s, we go back to 3d. Alright, once we've filled up 4p6, we've now used a total of 36 electrons, and so we can finish with 2 electrons in the 5s and 5 in the 4d. Also remember, there's an alternative way to do this, and that's to use the noble gas, the robophore. So the noble gas, the robophore technetium is krypton. Krypton accounting for those first 36 electrons. And so we could also have done this one as krypton, and then just filled in what comes after krypton. Krypton 5s2, 4d5. For cesium, specifically cesium plus, it's going to be the exact same process. The only thing that's going to change is that we have to go a little bit further, because we have an additional 11 electrons. But we fill the orbitals up in the same order. Again, we said we need 11 more electrons than what we had for technetium. So previously we had stopped at 4d5, we can put an additional 5 there, and then the last 6 can go into the 5p.